Now we will see use of dimensions or dimensional formula or dimensional analysis. There are three uses of dimensional analysis. There are three uses of dimensional analysis. First, to check the accuracy of various formula or equation. Principle of dimensional homogeneity. According to principle of dimensional homogeneity, the dimensions of each and every term on left hand side of the equation must be same as that of each and every term on right hand side. Note, if a formula is physically correct, it has to be dimensionally correct. But if a formula is dimensionally correct, it is not necessary that it is also physically correct. For example, check the validity of the equation x equal to ut plus half at square, where x is the distance travelled by a particle in time t, which starts at a speed u and has an acceleration a along the direction of motion. To check the validity, check the dimension of each and every term on left hand side and right hand side. Now, dimension of left hand side. On left hand side x is there and dimension of x is L. Now let us see the dimension on right hand side. Dimension of ut equal to LT minus 1 into t, that is L. Dimension of half at square equal to LT minus 2 into T2 equal to L, because half is dimensionless. Therefore, since in the equation dimensions on left hand side are equal to dimensions on right hand side, therefore the formula is dimensionally correct. Now let us see the second application of dimensional analysis. To convert the value of a physical quantity from one system of unit, to convert the value of a physical quantity from one system of unit to another system of units. Since magnitude of a physical quantity always remains constant, it will not change if we express it in some other unit. So, physical quantity Q equal to n into U equal to constant, where n is number and U is unit. So, n proportional 1 upon U. So, n is inversely proportional to U. So, we can say if n is more, then U will be less. So if n is bigger, U will be smaller, and vice versa. That is, if n is smaller, then U will be bigger. For example, 1 kilogram equal to 1000 gram. Since 1 is less than 1000, so kilogram is a bigger unit than gram. Let number and unit of a physical quantity in first and second system of units are n1 u1 and n2 u2 respectively, and dimensions of a physical quantity in mass, length and time are a, b, c respectively. So q equal to m, a, l, b, t, c. First system, second system, we can write n1 u1 equal to n2 u2, n1 m1a, l1b, t1c equal to n2, m2a, l2b, t2c. So n2 equal to n1 m1 upon m2 power a, l1 upon l2 power b, t1 upon t2 power c. With the help of this equation, we can convert value of a physical quantity from one system of unit to another system of unit. Now let us see the illustration to convert the value of a physical quantity from one system of unit to another system of unit. The value of gravitational constant capital G in MK system is 6.67 into 10 to the power minus 11 Newton meter square upon kilogram square. Convert this value into CGS unit. First system, second system, N1 equal to 6.67 into 10 to the power minus 11, N2 is unknown. In first system, M1 is measured in kilogram, L1 in meter, T1 in second. In second system, M2 is measured in gram, L2 in centimeter and T2 in